Hello, everyone. Welcome to the AIoT practice course. This course describes the convergence of AI and IoT and introduces the experiment case. This chapter describes the following contents. 1. AIoT Overview and General Knowledge of AI and IoT. 2. Embracing Technology and Transformation. 3. Probing Technologies with Scenario Analysis. 4. Connected HOV Cloud AIoT Solution. As IoT and AI technologies become mature, more and more enterprises regard AIoT as their main development direction. Since 2017, the word AIoT has become a buzz in the IoT industry. AIoT is the implementation and integration of AI and IoT in real-life applications. It is not a new technology, but a new application form of IoT. If IoT connects all common things that function independently through networks, then AIoT is to provide more intelligent features to connect all things in a real sense. AIoT is not simply combining AI and IoT. AI and IoT technologies are used to integrate data, knowledge, and intelligence through 5G networks based on big data and cloud computing, with semiconductors as algorithm carriers and cybersecurity as implementation assurance. More application scenarios can be implemented, and more possibilities can be realized when AI is applied at the application layer. AI can maximize the value of IoT, and IoT can provide data flows required by AI. Only by combining them can the advantages of IoT and AI be maximized. AI is a science and technology based on computer science, neuroscience, mathematics, philosophy, sociology, biology, and psychology. A major driving force of AI is to develop computer functions related to human intelligence, such as inference, learning, and problem solving. In short, AI is a new technical science that studies and develops theories, methods, and application systems for simulating and extending human intelligence. The basic conditions for achieving AI include data, algorithms, and computing power. Since 2012, the data volume surges, deep learning emerges, and the computing power is improved. AI starts to burst. Explosive data volume growth provides sufficient nutrients for AI. IDC, International Data Corporation, predicts that the global data volume will reach 40 ZB by 2020, and the data volume in China will reach 8.6 ZB, accounting for about 21% of the global data volume. In terms of algorithms, the emergence of deep learning breaks through the limitations of shallow learning algorithms used in the past and disrupts the algorithm design ideas in basic application fields such as voice recognition, semantic understanding, and computer vision. For computing power, the emergence of GPU, NPU, and FPGA dedicated chips makes the data processing speed no longer a bottleneck of AI development. Common AI technologies include traditional machine learning, deep learning, and cutting-edge reinforcement learning. Machine learning is the core of AI. Machine learning is mainly to design and analyze some algorithms that allow computers to automatically learn. These algorithms include decision tree algorithm, particle swarm optimization (PSO) algorithm, random forest algorithm, logistic regression algorithm, support vector machine (SVM) algorithm, genetic algorithm, naive Bayes algorithm, k-nearest neighbor method, greedy algorithm, k-means algorithm, AdaBoost algorithm, ant colony optimization (ACO) algorithm, neural network algorithm, and Markov algorithm. Deep learning is derived from the research of artificial neural network and multilayer perceptron is a type of deep learning structure. Deep learning is a new field in machine learning research. Its motivation is to establish neural networks that simulate the human brain for analysis and learning. including generative adversarial network (GAN), convolutional neural network (CNN), and recurrent neural network (RNN). Reinforcement learning is one of the paradigms and methodologies of machine learning. It describes and solves the problems that an intelligent entity maximizes the return or achieves a specific objective by learning policies during interaction with the environment. The main algorithms include Q-learning and Monte Carlo algorithms. There are many technical directions of AI, such as statistical learning, data mining, pattern recognition, machine vision, voice recognition, natural language processing, human-machine interaction, and expert systems. AI is widely used in our life. For example, voice translation, through natural language processing, including feature extraction, pattern matching criteria, and model training. Machines can convert voice signals into texts or commands, understanding human languages by sentences and their meanings. Machines can now deal with different accents, slang, background noises, and different persons' tones. Voice translation is commonly used in the voice input system, voice control system, and intelligent query system. Identity recognition can systematically understand and interpret visual input on a computer, and accurately identify abnormal people through learning. It can also be used in the clinical expert system to diagnose patients' diseases and for vehicle license plate recognition. Intelligent robots can perform tasks given by human beings. They have sensors that can detect data from the real world, such as light, heat, temperature, motion, sound, collision, and pressure. Efficient processors inside them, working together with multiple sensors and huge memory, demonstrate their intelligence and allow them to learn from mistakes to adapt to the new environment. For expert systems, some applications have been integrated with machines, software, and special information. They provide users with explanations and suggestions. For example, they can analyze the stock market and conduct quantitative transactions. In addition, there are machine vision, fingerprint recognition, iris recognition, palm print recognition, handwriting recognition, automatic planning, intelligent search, theorem proving, gaming, game design, automatic program design, intelligent control, language and image understanding, and genetic programming. AI has undoubtedly been applied in many areas. IoT is an extension and expansion of the Internet. It connects sensors with the Internet to form a giant network, implementing interconnection of people, machines, and things anytime, anywhere. The IoT architecture is complex. The IoT construction consists of 4 parts. The first part is necessary device hardware. The things in the IoT devices serve as interfaces between the real world and the digital world, with different sizes, shapes, and technical complexity. Their attributes depend on the tasks they need to perform in a particular IoT deployment project. IoT devices include many types of sensor devices and networked devices. Second, device software. The reason why networked devices become intelligent. Software is responsible for communicating with the cloud, collecting data, integrating devices, and performing real-time data analysis on the IoT networks. In addition, device software can visualize users' data and allow devices to interact with the IoT system. It also contributes to communications. After the device hardware and software are in place, the focus turns to communications, the ways and means of intelligent things exchanging information with the IoT world. The communications layer includes physical connection solutions such as mobile, satellite, and local area networks and specific protocols such as COAP, MQTT, and LWM2 millions used in different IoT environments. Finally, The platform layer. With the help of intelligent hardware and installed software, devices can sense what is happening around them and communicate with users through specific communications channels. The IoT platform can collect, manage, process, analyze, and display all data in a user-friendly manner. Therefore, the value of this platform lies not only in its data collection and management capabilities, but also in its ability to discover potential data value. There are many IoT platforms in the market. The platform to be selected depends on the requirements of a specific IoT project and factors such as the architecture and IoT technology stack, reliability, customized attributes, protocols used, hardware agnosticism, security, and cost-effectiveness. In addition, the IoT platform can be installed locally or deployed on the cloud. IoT is now Internet of Everything. It uses different detectors to generate the most popular big data and divides the data into multiple parts for the required units or people. Such a network can connect people and things, making our life smart and intelligent. Devices lie in the bottom layer of the IoT architecture. They are responsible for information collection and signal processing. This layer involves IoT operating systems, chips, communications modules, and various sensors. The upper layer is the pipe, which is responsible for the access and data transmission of underlying IoT devices, including wired and wireless networks. Wireless networks include 2G, 3G, 4G, 5G, NB-IoT, EMTC, LoRa, ELT, Wi-Fi, and Zigbee. On the cloud is an IoT platform deployed. It is responsible for device access, device management, data integration and storage, and provides APIs for upper layer applications. The upmost layer is the application layer, which is responsible for data presentation, user interaction, and service logic processing. It is the interface for direct contact with end users. Applications from a variety of industries are supported, such as Smart Campus, IoV, Smart City, and Smart Industry. There are a volume of IoT application scenarios. For example, a shared bicycle is integrated with an embedded chip, GPS module, and SIM card in the lock to monitor the location of the bicycle at any time. A mobile app is used to display nearby bicycles and guide users to find a bicycle on the map. Users can unlock the bicycle by scanning the QR code. The app supports online payment and cycling route recording. In the smart healthcare scenarios, patients can easily get registered through a mobile app, which effectively reduces the trouble of queuing for registration and prevents scalper from selling high-priced tickets. The sensing technologies can remotely monitor and manage physiological status such as heartbeat frequency, energy consumption, and blood pressure of a person. The RFID technology can monitor and manage medical devices and articles, making them visualized and hospitals digitalized. Therefore, IoT technologies can effectively help hospitals implement intelligent management of people and things. The radio frequency identification technology can help implement unmanned vehicle supervision, navigation, and parking. An in-vehicle device can automatically display navigation information and guide the driver to a nearest parking space. Smart home is the most important part of IoT that is closest to our daily life. The mature application of IoT technologies accelerates the development of smart home. IoT technologies are used to connect devices in your home to your mobile devices to remotely control garage door locks, lights, curtains, and other appliances, implementing intelligent device management. In the retail field, diversified IoT applications exist. For example, the mature warehousing management system and smart retail scenarios.